then these are some of those that we previously talked about. So we're going to fill in this chart over here to the side based on these pictures. So on number 1, what's the short leg for number 1? 3, good. Which means the long leg is 4. And then we have to find the hypotenuse. So how do you find the hypotenuse? Right. And our a squared is 3, right? 3 squared would give us 9, plus 4 squared, which would be, right? And 9 plus 16 is 25, and that's going to give me c squared, but we just want c, right? So I take the square root of 25, which is 5. So the hypotenuse here would be 5. All right. On number 2, do we know the short leg? Yeah, what is the short leg? 5. Do we know the long leg? No, we don't know the long leg on this one, but we do know the hypotenuse, right? The hypotenuse is 13. So to find the hypotenuse, instead of adding a and b, what am I going to have to do to find the? Subtract them, right? So 5 squared and 13 squared. I would need to subtract those two. What is 13 squared? Good. Minus that 25. And what is 169 minus 25? Right. And we take the square root. The square root would be 12, right? All right. On number 3, do we know the short leg? Do we know the long leg? No. So we have the hypotenuse. So again, to find those, we would subtract, right? So what is 25 squared? Good. And 7 squared is 49. So what do we get when we subtract? We need to take the square root. We end up with good. All right. For number 4, do we know the short leg this time? No, that's the piece we don't know. What's the length of the long leg? Of the long leg, 15, and then the hypotenuse is. So again, to find this, we would need to subtract, right? So we would need to do 17 squared. What is 17 squared? Right. Minus 15 squared, which is good. And what do you get when you subtract 289 and 225? 64, and then the square root of 64 is 8. Very good. All right, we got 2 more. For number 5, what are we missing? The hypotenuse. Okay, so this time we're going to add them. So I've got 9 squared, which is 81, right? Plus 40 squared, which would be, right? What am I going to get when I add those and take the square roots? Good. Okay. And last one. What are we missing on number 6? Short leg, right. So I've got my long leg, and I've got the hypotenuse. So we're going to have to subtract, what's 61 squared? Yes. Minus 60 squared, which is good. And when we subtract those and take the square root, we end up with what? Yes, and then the square root of 121 is very good. All right, so we can use Pythagorean theorem to find any of the missing sides in a right triangle, right? As long as we know 2 of them. All right, so it says each set of numbers below has a common factor. Find that factor, factor it out of the set, and then determine to which common triple the set relates. Use your chart above to help you fill in the blanks. So these are the most common Pythagorean triples. If you have another Pythagorean triple, it's going to be a multiple of one of these. So if you will just memorize these 6, then you won't have to do Pythagorean theorem every time because it's going to just be a multiple of one of these. Okay? So on number 7, what would be the greatest common factor between those 3 numbers there? 4, right. So if I divided all of these by 4, what do we end up with for our numbers? 5 and 12, and you don't need to do the math. Look up here, guys. Once you know it's 5 and 12, it's going to have to be 13. Okay, so if you know your chart, then you don't have to solve for all of them. All right, on number 8, what's our common factor there? 2. Right. So I can divide all of those by 2. When I divide by 2, what are my 3 numbers? 3, 4, 5. Good. Okay. On number 9, what's our common factor there? 3. So if I divide all of those by 3, what are our numbers? Good. All right, and then on that last one, we can take out what from all of those? Square root of 3. Right. So if I divide all of them by square root of 3, then the square root of 3 just divides out, and I'm left with the numbers. So my numbers end up being, there we go. So if you will just memorize those 6 from the chart, then you won't actually have to solve for missing pieces. You can just realize that they're all going to be multiples of those if it's going to be a Pythagorean theorem or right triangle. All right, so then it says, without using Pythagorean theorem, you need to write in the missing dimensions. Hint, if you'll factor out that common factor first, it's going to be one from your chart, okay? So, on number 11, what should go in the blank there? Right. And on number 12, what goes in our blank? 17. On number 12? Right here. 12. Okay, and on number 13, so this is one where you're going to have to take out your factor to see which one it matches. What's going to be our factor between 18 and 30? Bigger. 6. Okay, so 18 divided by 6 gives me 3, and 30 divided by 6 gives me 5. So that means it must be 4 in the middle, but to put it back in the blank, I need to multiply it by 6, right? So what am I going to put in the blank? 24. Okay. All right, on 14. And we don't want to have a fraction, obviously, right? So how do I get rid of that fraction? We what? Multiply by 2, right. So that's going to turn this into 8, this into just 15. So what goes with 8 and 15? 17. But for it to fit the pattern, we have to do what? Divide by 2. So in the blank, I'll have 17 over 2. Okay, last one. What can I divide 90 and 400 by? 10. So I've got 9, 40. What's going to be next? 41. But for it to match the pattern, what do we need to multiply it by? 10. So it's going to end up being 410. All right. Okay, so if you will just memorize that 6 sets of Pythagorean triples, you don't have to work them out every time. All right, flip it over onto the back. And this part may or may not be new information to you. So We're going to be talking about the converse of Pythagorean theorem. Remember, we've talked about converses before. Basically, it just means kind of the opposite, right? We always use that word not. Okay, so we are going to fill in this chart and see what we can conclude from what we're seeing here. So they tell us what the links are here. Let's fill in the first 4 blanks in each row. So we've got our 5, 6, and 7. So out of those 3 numbers, which one is C? The 7. And what's 7 squared? Good. Okay, which one of those numbers would be my A? 5, which when we square it would be good. And then that would mean that B has to be 6. 36. And then it says to add your A squared and B squared. So what is 25 plus 36? 61. Okay. Now over here it says they are asking if we want to say that this one is acute, obtuse, or right. So we may not know exactly what to put in this blank. Let's continue filling in the chart and see if we can conclude what we should put in that last column. All right, so on the next row, what's my C? 5. So when we square it, we get, what's A squared going to be? And B squared? So what will A squared plus B squared be? 25. All right. And then for the next row, what's my C squared going to be? 169. Good. And what's A squared? Good. And B squared? And what's A squared plus B squared? 145. All right, and then last row, what's C squared? Okay. All right, and then what is our A squared? And B squared? And what do we get when we add A squared and B squared? What did you say? I'm sorry.
I said 160.
Yes. That would bring it up to 60. Yes, 160. Okay. So with our Pythagorean theorem, what exactly does it read as? What is the Pythagorean theorem? Right. Okay. So A squared plus B squared equals C squared. And Pythagorean theorem works for right triangles, right? Okay. So this means we have a right triangle. So let's check and see if any of these gave us that. So this would mean whatever we got for A squared plus B squared would have to be the same as C squared. Do we have that on any of these rows? Yes. Right here, we got that these were both 25. So this has to be a what kind of a triangle? All right. Did it happen anywhere else? Yeah, on that bottom one, right? Okay. All right, so those must be the numbers that are determining what kind of triangle we have. So let's look. They already filled in that this one was obtuse. Let's compare those 2 numbers. So was C squared greater than 61 or less than 61? Okay, so that must mean any time that C squared is greater than your A squared plus B squared, that we get 61. Does that happen anywhere else? Yeah, right here, right? So this must also be obtuse. And then the only one we haven't filled in, when we compare those, it's the other way around, right? C squared is less than my A squared plus B squared. So this must mean this case gives us an acute. Okay? All right, so for what kind of triangle did we say they would be equal? A right triangle. Good. So if it's equal, then we have a right triangle. Okay? All right, if it's not equal and C squared is less than my A squared plus B squared, what kind of triangle did we say that would give us? Acute. Good. And when c squared is greater than my a squared plus b squared, that tells us we have obtuse. All right. So you're going to solve using Pythagorean theorem. You just don't know if it's going to be equal to, less than, or greater than. So you'll actually have to simplify using Pythagorean theorem, square the numbers, and see. Is it less than, greater than, or equal to?